today we're early. But I guess I didn't know that we do have a big, huge prize to raffle off this week. And I guess I should have put it in the mailing out. So tonight we are raffling off a ticket to the conference. Just the, it's not the tutorials, but the sessions, which up until March 31st, that's like a $750 charge, isn't it? So it's a good prize instead of a book. So we will raffle off one, maybe two, tonight. And we have to thank our sponsors for these things. Percona gives us the pizza, so thanks Percona. They also help us get speakers. And then we have O'Reilly, who are always so great about getting us books. And MySQL, I guess it's Oracle, donated some passes. And then, of course, we have GameSpot, who does the space, and Mike, and all that. So that's the end of my official announcements. Does anybody have any announcements they want to make? But you have to talk into this, because there's people across the...
Hello everyone, we are two Superinfo students with Edouard. It's a French IT school which is here in San Francisco. This school gives a master degree, and we're looking for an internship. So if you want more information about Superinfo, or if you have job opportunities, come to see us after the meetup. Thank you.
Did you guys get that? Because it didn't have them mic'd. Internships. Two guys looking for interns. Does anybody else have jobs or want a job? Oh, I'll let you do that after.
Yeah, I'm working on a mobile community bulletin board system. I've got it on my iPhone here. I'd be happy to show it to folks. We are hiring a really kick-ass developer. So if that's you, let's talk. Let's see. Oh, my language was bad?
No. PHP, Java, Ruby on Rails.
Yeah, we're coding in Ruby. We're using, I know this is a MySQL crowd. We're using PostGIS for GIS stuff. We've got a lot of other tricks up our sleeves using Amazon's cloud. And it's a growing infrastructure. We've got a lot of interesting challenges ahead, so we're looking for smart people to charge ahead with us.
Thanks. Anybody else?
I forgot to mention CBS Interactive, GameSpot.com, CNET.com, BNet, Find Articles. There's a whole host of sites, CBS News, CBS Sports. We're hiring for DBAs, MySQL and Oracle. We're also looking for PHP, Ruby, Java, Perl, Python, anybody who can code. Every business unit does a little bit different language stuff, so there's a lot of different opportunities and a lot of different verticals. So if you're interested, cbsinteractive.com/jobs, and that's it for me.
Your job.
So I'm with Percona. We're performance consultants. We're always looking for very senior performance consultants who are intimately familiar with MySQL, MongoDB, and the full LAMP stack. If you're interested, come talk to me after. Aaron, do you need this back? Oh. No, I'm fine. How's the audio? Too loud, too soft? Getting thumbs up, blank stares? Perfect. My name is Ryan Lowe. I'm the director of Percona's Americas Consulting Group, and I'm here this evening to talk to you about the HandlerSocket plugin for MySQL. I want to start off with a quick question. How many of you are running HandlerSocket in production? All right, how many of you are evaluating it for production? How many of you have no idea what HandlerSocket is? Awesome. Okay. So we'll cover what HandlerSocket is, how to deploy it, things like that. So I actually want to answer 5 basic questions today. What is HandlerSocket? Where does it fit in your application stack? Why would you want to use HandlerSocket as opposed to another solution? How do you install it? and how do you use it. I'll end with some of the limitations and gotchas that you need to keep in mind as you deploy it in production. And then at the end, we should have time for Q&A. This should just be about an hour talk. Please ask questions at any point during the presentation. I have a webinar in a couple of weeks on the same topic, so anything that I can clarify or improve on, I'll appreciate it. So what is HandlerSocket? In short, it is a NoSQL interface to MySQL. It bypasses the SQL interface and interacts directly with the storage engine. And this avoids things like parsing SQL statements, opening and locking tables, making SQL execution plans, and unlocking and closing tables. It also avoids a lot of concurrency controls. If you're anything like me, when you first heard about HandlerSocket, you thought about the MySQL handler statements. These also are supposed to provide direct access to the storage engine. Unfortunately, the handler statements, they still require parsing and opening and closing of tables. They are faster than just regular normal select statements, but the handler statements can be significantly improved upon, hence the development of HandlerSocket. It's a daemon plugin to MySQL. It has its own TCP/IP listener. It currently speaks its own proprietary text-based protocol, but it's very simple. I'm sure in the near medium term we'll see some improvements. What I'd really like to see is have it speak memcached and have some sort of binary protocol. As of last week, there were a whole bunch of clients and a whole bunch of very new clients. There's JavaScript, several in Ruby, several in PHP, a few in Python, Scala, I don't even know. Unfortunately, as with a lot of these NoSQL solutions, a weakness lies in the clients. Right? The clients are generally written by students or people who don't really have a lot of experience, and this is just an interesting thing for them to do, so they don't scale very well, and there are a lot of immediate bottlenecks. In my benchmarking, the only real client is the C++ client. The rest of them are multiple times slower. I do use Perl for my benchmarks because it's just faster to write scripts and do tests with that, but if you're going to deploy it in production today, use the C++ client because none of the other clients are really production ready. The overall architecture, as pictured here, is very simple. The client can either use libmysql to talk to MySQL or libhs client to talk to HandlerSocket. And the important thing to note here is that they're both talking to the same data source. And this is really what makes HandlerSocket a very compelling alternative to some of the other NoSQL solutions. You'll see here that it bypasses both the listener and the SQL layer. People typically don't think that the listener is a very heavy or resource intensive, but if you've got granular grant statements and permissions, or if you're using host names that don't have skip name resolve set, it can be very expensive DNS lookups. So the listener for MySQL, libmysql, can be a bottleneck in certain situations. And the SQL layer, the parsing of MySQL, it's non-trivial and it is expensive to parse an SQL statement. As far as required client-side modifications, if you're going to integrate this with your application, it's usually just as simple as installing the client libraries. You can see here from the picture that it theoretically would support any storage engine, but in reality we only want to use it with InnoDB because that's the only one that's really been tested. So over the years, there have been a number of other attempts to add NoSQL interfaces to MySQL. And the three major ones are, first is NDB API. This is in wide use today in the MySQL cluster world. In fact, the best NDB benchmarks that you're going to see are usually done using the NDB API. Lots of my customers ask me, oh, which of these non-relational systems, like Cassandra or Redis or Tokyo, which one has the most production use and is the most stable? And I always tell them that NDB is the original NoSQL solution when you're using, if you do use the NDB API. It's fast, it's scalable, it's stable, it's all the things that Cassandra, I guess, is not. The second is the Prime-based blob streaming engine. This functionality was released, I think, almost 3 years ago, but it never really took off. Paul McCullough wrote a very insightful blog post a couple of months ago speculating as to why it didn't get popular. I suspect the core reason is the name. The blob streaming engine doesn't really emote NoSQL access. And at the time that it was released, There weren't all these other options out there for NoSQL, so it wasn't proven as a potential solution in the web world. And it didn't work with any standard storage engines like InnoDB or MyISO. And finally, MyCached. This is a predecessor to HandlerSocket. It was written by, and I'm going to butcher this, is Kazuoku. It never really made it out of a prototype stage, so it didn't really gain any widespread support. I've seen people playing with it and testing it as a kind of a toy, but never seen it in any production environment. So where does HandlerSocket fit in your application stack? As recently as a few years ago, if somebody said they were running on the LAMP stack, they literally meant they were running Linux, Apache, MySQL, and Python or Perl or PHP. But today, when somebody says they're on LAMP, I hear GLaMRump, right? Gearman, Linux, Apache, Nginx, Memcached, Redis, MySQL, and then Python, Perl, PHP, whatever. So the standard application stack has gotten exponentially more complex over the years. And this is in large part because smart developers are using the right tool for the job. And a lot of web applications these days do have some, at least subset of their usage pattern that lends itself to a key value store where you're doing a lot of primary key lookups. In fact, some applications are entirely composed of this key value lookup. So let's walk through a couple of use cases. The first type of application that comes to mind is a Facebook game. These are almost entirely composed of select star from some table where Facebook ID is some number. Or Twitter applications, which are essentially the same thing. It's just a primary key lookup on a 64-bit ID, whether it's Facebook ID or Twitter ID. And these applications, Facebook and Twitter applications, were really the first to dive into adopting NoSQL technologies like Cassandra and Tokyo. And I know that because a lot of my customers were doing it at the time. But what they found out was that there was usually some small part of their application that did not lend itself well to a Tokyo or a Cassandra. And so what they ended up having to do is completely abandon that attempts to move to a NoSQL data store or have duplicate data. Some of their data in MySQL or a relational data store and some in Cassandra or a non-SQL data store. And the problem with that is it introduces a lot of application complexity because you have to introduce management, right? There has to be conflict resolution. You have to pick an authoritative source when they get out of sync, not if they get out of sync, but when they get out of sync. And by having this, you're effectively reinventing the wheel. All it does is result in a lot of extra development time and a lot of extra bugs and a lot of hassle for the developers. So that's really a compelling reason that behind HandlerSocket, because there is a single authoritative data source that you can use with SQL and standard CRUD. So Facebook and Twitter applications aside, because some of us have real applications, there are other real-world uses for this. First, for example, session management, right? That's a very simple use case that, a lot of, when Memcached first came out, everybody said, oh, perfect, session management. There's been a lot of bad noise about HandlerSocket not having atomic operations, which can be problematic in some systems, think banking, but for most of us, session management is one of those things where close is good enough. If every once in a while a couple of your users have to re-log in, or every couple of weeks there's an extra session record for a user that'll get cleaned up in a few hours, most of the time that just doesn't matter. An even better use case would be log processing. A lot of people try to do that in MySQL and fail, especially in a replicated environment, because the writes all get serialized on the master and then go to the slave. So the traditional wisdom is that if you don't pre-aggregate the logs, then you can't do log processing in MySQL. Well, HandlerSocket gives you very fast write access, so it's effectively going to increase the length of the runway before you have to start pre-aggregating your logs. And this is one of the actually benchmarks that I want to do. I want to take a look at load data versus a bulk insert from HandlerSocket and see kind of where they weigh up, because if the write performance for HandlerSocket is comparable or even a little bit less, it can just be a very good solution for a lot of problems. Another example along the same lines is click tracking. So we do see real-world examples here. The bottom line is there are a lot of opportunities to use a key value lookup instead of a full-fledged RDBMS, and developers have a lot of options to choose from. Having to not deal with stale data, having an authoritative data source, getting rid of all data synchronization issues, these are all very compelling reasons to choose HandlerSocket. Now, each technology, of course, has their own weakness, but it's just important to understand what the weaknesses are and how they will fit in your application environment. Lots of text for that, huh? All right, so why use HandlerSocket? There are a variety of reasons. First, application developers are going to be familiar with the way to access it. Simple CRUD commands, it's the same way you access memcached. Secondly, bypassing the SQL layer. It's important, and we'll show you why bypassing the SQL layer is important in the next couple of slides. Use the right tool for the right job. You're here probably because either you're here for the pizza and you had no idea what HandlerSocket was, or at least part of your workload lends itself well to key value lookup, primary key lookup. So you can just build upon your existing software stack instead of introducing another platform. So finally, performance. HandlerSocket is ridiculously fast. We've all seen the benchmarks, and in the next couple of slides, we'll show you why it's faster. This used to be a graph the last time I gave this presentation, but nobody liked the graph. Everybody asked for numbers, so here they are. Akira Higuchi gathered some oprofile statistics while doing a bunch of primary key selects from MySQL, and then did essentially the same reads from HandlerSocket. This first slide shows the oh, wait, I'm not supposed to move, am I? Shows the top resource hogs. In mid-MySQL, no, it's fine, no, I'll point. You can see that MySQL parse, which actually, does the parsing of the SQL statements, and you can see the results of MySQL parse basically by doing an explain extended on a query, and you'll see a much different query that MySQL sees than what you issued it. So MySQL parse takes, what, 7%, make join statistics, join optimize, these are all basically SQL overhead, and combined they amount to over 10%. And you can see on the right-hand set of numbers that these are all eliminated when you use HandlerSocket. You can clearly see here that the majority of time is now spent inside of InnoDB. And that's really nice because we know that InnoDB continues to improve, mutexes continue to be removed, and scalability continues to be improved. These numbers, by the way, I have no idea if these were, what version of 5.1 these were on, or what the setup was. I assume that the C++ client was used, but I just don't know. So when I gave this presentation last time, I was told that these numbers were spurious because this is just a standard SQL access versus HandlerSocket, when a lot of the benefits of HandlerSocket you would think you can get from using prepared statements. So yesterday I redid a benchmark using 5.156. So the first set of numbers over here, it looks very much like the original set. This is just a regular Perl client using regular SQL statements. On the right you see with prepared statements. And the first thing that you notice is that MySQL parse is gone. It's no longer in the top 10, which is a big win. But we still see things like make join statistics, join optimize. This is still SQL overhead, and these did not go away. So, try to use prepared statements if MySQL parse is your biggest resource user, and if that doesn't work, then we can still improve that by using HandlerSocket. Promise I won't say it again. They are good in very specific circumstances, which is probably not anything at CVSI. So in the final graph here, you see it looks a lot like the other HandlerSocket benchmark. I'm using the Perl client, so that might explain some of the differences, and the differences might be attributed to a newer version of MySQL and the InnoDB plugin. And there's one more point of comparison that I wanted to have, but I didn't have time to benchmark it, and that was using MySQL's handler functions that I mentioned earlier. I typically, though, don't see those used by anybody in production. And that's just because developers don't necessarily have a command of the handler functions, because most of the development these days is, Ruby on Rails or some such, where you're already abstracted from the database, and Ruby, unless you bypass it, it's never going to generate a handler statement, right? So when I benchmark it, I do suspect that it'll have a lot more similarities to the HandlerSocket oprofile results than the prepared statements or the regular ones. Everybody got that? All right. So, to summarize, why would you want to use HandlerSocket? Well, for libMySQL, lots of CPU time was spent in MySQLD. Parsing SQL is slow, and we avoid that. And what you didn't see here is that schedule is called frequently within the kernel. And HandlerSocket, most CPU time is consumed inside the kernel, which is good. But inside of MySQL, InnoDB consumes most of the CPU, and that's good for the reasons discussed before. And then schedule, again, is not called as frequently. And I intentionally omitted any numbers and timing information because the point is to just show what it gets rid of. In reality, unless you're doing lots and lots of primary key lookups, MySQL parse is probably not going to be your biggest bottleneck, right? Your biggest bottleneck is going to be those queries that are actually doing joins and things like that. But for this primary key select workload, that can be manifest itself as the primary bottleneck. So how to install HandlerSocket? Now we're getting to kind of the operational side of things. There are two basic approaches. I prefer this first method because it takes 5 commands and I can do it in under a minute. And as a consultant who works on dozens, if not hundreds, of customer systems, I always like having a repeatable way of installing something and making sure that the versioning information is correct. So I'll use the Percona server, the Percona builds, so that I know if I'm installing 5.156, it's associated with this particular version of HandlerSocket, which is really nice. So first we set up the Percona Run repository, which is a simple RPM. Install the Percona server packages, the server clients, shared, compat, Devel, things like that. And then enable the plugin in my.cnf. This is just a couple of additional lines where you specify what port things listen on, and things like that. We'll get into that in the next couple of slides. And then install the plugin, which is very simple. It's just the install plugin command that you would use on the MySQL command line. And then verify and test. The easiest way to verify if HandlerSocket is running is simply to telnet to the port 9999 or whatever you assigned it to and issue a couple of commands. And I'll show you how to issue commands for HandlerSocket via telnet the next few slides. So the second approach is to compile from source. And this is always fun for people because you get to learn what's involved and you get to see what packages are required. But again, as a consultant who works on a lot of separate projects, it's really important to me to know how things got installed. For example, I wouldn't know what version of GCC you're using. I don't know what version of MySQL HandlerSocket was built against. I don't even know if you actually got a HandlerSocket source correctly, right? You could have changed things and it would still compile depending on what you changed. So it's important from my perspective to install in a consistent way. Anyway, the steps are fairly explanatory. Install GCC and your other development packages, install source RPMs, get the source, build it, install it, and then enable the plugin, install the plugin, and verify and test. All right, so HandlerSocket configuration is fairly simple. They've only introduced about 15 new configuration variables, and the rest of HandlerSocket tuning is done by simply tuning the storage engine configuration variables as you normally would. So the InnoDB buffer pool, things like that. So from a practical perspective, these 5 variables are the ones that you need to know to get started. The first is HandlerSocket port. This specifies the port on which the read-only listener will listen. And by tradition, we use port 9998. Next is HandlerSocket port WR. This specifies where the listener for HandlerSocket writes will listen. By convention, we do 9999. Now, it's not uncommon to leave HandlerSocket port WR empty or just not in my.cnf because so that we disable the write listener, because a lot of the value in this key value lookup is in read operations, less so in write operations. And especially true because we don't have atomic operations, right? So a lot of people, when they evaluate it, they say, okay, we're going to do all of our reads via HandlerSocket and all of our writes via SQL. And this is especially true a few months ago. There were some really, really bad bugs or incomplete features in HandlerSocket where it wouldn't invalidate the query cache so you could get stale data, and it was a mess. So a lot of people just started benchmarking that way, which is why when you read the literature, you don't see a lot of benchmarks for write operations and things like that. But I expect to see more of that now that these critical bugs have been fixed. Next is HandlerSocket ePoll. This specifies whether HandlerSocket should use ePoll for I/O multiplexing, and this is another one that I want to benchmark. HandlerSocket threads, this is the number of worker threads for read requests only. The documentation says it should be the CPU cores times 2. So if you've got an 8-core box, you want 16 threads. But again, I recommend benchmarking your system and seeing what works best for you. Finally, how many write threads? Typically, this is 1, unless you have a very compelling reason. So those are the basic options. In these slides, we'll go through some of the more esoteric ones. HandlerSocket verbose is exactly what it sounds like. It controls the verbosity of the logs. The range is from 0 to 10,000, but I actually did a bunch of spot checks, and it's not nearly that granular. So I tend to go either 0 or 10,000. And not only is it not all that granular, the error messaging is not all that useful. For example, the error message for trying to access a table that doesn't exist is the same as trying to access a database that doesn't exist. So if you start having to go through the logs and dealing with that, you'll quickly appreciate MySQL's error messaging. HandlerSocket address, this is the address to bind to. It defaults to 0.0.0.0. Timeout is how long it takes to time out. The backlog specifies the length of the listen backlog. And this is where you have to really know your application workload. How many items do you see in the backlog before it starts to affect the end user experience, right? So after all, that's really the only metric that matters, is end user experience. So I generally leave this at the default. And unfortunately, this is one of those things, the backlog size, that should be graphable via cacti, or at least exposed so that we can see how much of the backlog is used. So I'll put in that feature request. Finally, the HandlerSocket sum buffer, it specifies the maximum socket sum buffer in bytes. Unless you have a very compelling reason, I set this to 0, which means match the system level setting for this. No, I've requested cacti graphs. Well, let's skip ahead a couple of slides. These are the status counters that it exposes are table open, table close, table lock, and table unlock. They're exactly what they sound like, and they're incredibly uninteresting. At some point, I hope to get more diagnostic information out of HandlerSocket, but in reality, it's very simple. So there are only a few more things to expose. But no, we don't have cacti graphs yet. Don't you have project admin status on the MySQL cacti graphs?
No.
You submit those, we'll accept them. Exactly. The HandlerSocket receive buffer, again, set it to 0 and let it match the operating system settings unless you have a compelling reason, which I struggle to imagine why one would do that. The read size specifies the minimum length of the HandlerSocket request buffer. So a larger value here is useful for making larger requests, but it's a trade-off between speed and memory usage, or additional memory consumption. So take the time to understand the average request size that you make. Are these single row lookups, or are you doing bulk requests, or how big are your rows, and size accordingly. So again, take the time to understand your application before you fully deploy this into production. And finally, the WR lock timeout, exactly what it sounds like. It sets the lock timeout in seconds. All right. That was the operational side of things. Questions, comments? All right. So we'll move on of how to use HandlerSocket. So now we know why we should use it and how to set it up. Let's talk about how we can use it. So for the purpose of this exercise, let's assume we have a table called T1 in the test database. It's described as follows, and please remember this because we'll be referencing it in the next few slides. It's got ID and val, where ID is the primary key, and there's an index on val. It's basically as simple as it gets. So we're going to insert a few values into the table, 1, 2, 3, 4, and 5. So this is what it looks like when we tell that to port 9999, which is the read-write port on HandlerSocket. The HandlerSocket protocol is a simple line-based request-response protocol. So the request-response consists of a single line. But requests can be pipelined, so you can issue multiple requests at once and receive responses for them one at a time. In this example, again, telnet it to 9999. And issued the following command, which will open an index that we can later use. HandlerSocket is based on indexes. You have to, it's like in SQL, you can select star from table 1 where column equals whatever. And that column doesn't have to be indexed, right? But that's poor performance. We generally like to index like that. But HandlerSocket only operates on indexes. So the command is P. That just tells HandlerSocket we're going to open an index. Tab, don't put space. This is a tab. If you put space, you'll just get an error. And it's very difficult if you don't realize that up front. P tab 0. 0 is a unique identifier for your session that you're going to use to refer to this index. It's a 32-bit integer. If you put an integer that's larger than that, MySQL will crash. So don't do that. There's not a lot of error checking. And it's unique within your session. So if I assign this index an ID of 0, you can have a separate index with an ID of 0. If I try to assign another index of 0 while one is already open, it simply closes the first index and opens a new index. So tab test. Test is the name of the database that we want to use. Tab T1, that's the table name. Tab primary, that's the name of the key. So here we're opening the primary key. And then ID, comma, val. This is a comma-separated value or comma-separated list of columns that we want to access in this index. And you have to specify them at the beginning. You can't open an index with 2 columns and then add a column later. So my best practice is to generally, unless you have a table structure that has a lot of columns that you're not going to access, is just to open everything. And that actually makes it easier for write operations as well, or at least it makes it more clear for people who are going to read your code. So after val, we hit enter, and this is how HandlerSocket knows that it's the end of a command. The next line is the HandlerSocket response. In this, the simplest of cases, it returns 2 data points. The first is the error code, and that's 0. So if we ever see the first response data point be anything other than 0, we know that there's been an error. The second is the number of columns in the result set. So I mentioned that this is an error code, 0 success, and there are a bunch of other non-zero error codes, but again, they're not terribly helpful, right? So you've got to do a lot of trial and error if you don't get things right on the first time. So next we're going to enter a read operation. This is a green line, 0 equals 1, 1. The first is 0. This says which index we want to access, and this is the primary key on T1. Tab equals. We're using an equal sign here because we want to do an individual primary key lookup. The protocol supports equal to, greater than, or equal to, less than, and less than or equal to. And the string comparisons are done in the same way that they normally would if you were using just normal query. So after the equal sign, we have vn, and this indicates the length of the trailing parameters. When we look at an actual client and we look at the Perl client, you'll see that this is just an array ref. So this actually isn't needed when we're using anything except telnet. And finally, since we only have one parameter following vlem, that is 1. And basically what this is this equates to select ID val from test.t1, where ID equals 1, limit 1. So this is going to return 0, success, you know, how many columns were returned? 1 and 1. So if you recall, we inserted 1, 1, and that's what it should return to us. So 0, 2, 1, 1, right? Oh, that's just a feature of when you open an index. Yeah, so you mean right here? Yeah. Yeah, 0 tab 1 is the, okay, your index is open response. There are a couple of other idiosyncrasies like that as well. They're abstracted once you use a client. You don't have to deal with this, but I think this gives you a much better insight into what's going on rather than just using a Perl client or something. And it allows you to be able to troubleshoot later on. So 0, 2, 1, 1. It's pretty straightforward, yeah?
So val is not part of the primary key, right? So how is it that are you just specifying that the where
Right, you have to access by it.
from the primary, but
Right, so you can use, it's like where ID equals or where val equals. So you can select an arbitrary number of columns that are not in the index, but like the where clause. So when,
the lookup.
right, so we said primary, that means that the where is against ID. And it gets a little more complicated as I have, you know, if the primary key here were ID comma val, so multi-column index, then you'd have to do stuff a little bit different. But yeah, it just refers to the column in the index.
So if it wasn't the primary key, that's by X, like IX.
Right, so if we were opening up the index on val, we would say instead of primary, IX underscore val, and we could do this exact same thing, except for this query, we would say 0 equals the number 1 and then ONE, and then it would return, right, so ONE, and it would return the exact same thing. Any more questions before we go on to something a little more complicated? All right. So here we're issuing a query for all rows where ID is greater than 3, right? So select ID comma val from test.t1 where ID, right, and we got all that information from 0, this is the index ID, where ID is greater than 3.
What's
The
the one?
1 says how many arguments follow this, right? So if I had a multi-column index like ID and val, I could have 3 for ID and then something else for val, right? So when we use,
It's like RC.
right, so consider this, right? So here we have this, but we don't have that construct in just a telnet session. So it abstracts it for us. So we have to tell it how many things are coming after. So yeah, select star from T1 where ID is greater than 3. We expect, right, 3, 4, or 4 and 5, right? So we expect 2 rows. We only got 1. And that's because there is an implicit limit 1 offset 0 when we issue this, right? So if we wanted to get all of the results in actuality where ID is greater than 3, we'd say select star from T1 where ID is greater than 3, limit 100, right? And I actually found that incredibly irritating because it implies that you know exactly how many rows you want before you issue the query, which is fine if you're just doing primary key lookups, you know, single row lookups or for paginated displays, but it doesn't work when you have an arbitrarily large set of data that you want to get back. So I find that quirk somewhat irritating. You don't do a count star, no.
So what if you don't know the number of records?
Don't use HandlerSocket. Or at least don't use it yet. Right, so think about it. Use the Facebook example, right? You don't need a count. You need Facebook ID 1, 2, 3, 4, 5, right? So you get 1, 2, 3, 4, 5, and you just do whatever it is with the structure you get back. What use case do you think?
Facebook example, let's say you want to get a list of somebody's friends.
You're not allowed to store that, and you go through the Facebook API.
Well, you can store the ID numbers, though.
Oh, okay. Well, then you would have a friends table, right? And then my Facebook ID is 1, 2, 3, 4, 5, and then we can have some serialized array, right? So you just get the serialized array back, you unserialize it, and it's just a primary key lookup. You're getting 2 columns, right? The integer column, which is my ID, and then serialized array of my friends list, or something like that. It's really fast. It's not efficient to write it, but that type of read operation would be very fast.
So is like a count star on the feature list? Is that going to be added eventually?
Not even in NLDB yet.
Well,
you can fake it, right? So you can just put some arbitrarily large limit that you know is larger. So if you think, oh, I might have 1 million, my limit is 10 million, right? Then it'll tell you how many rows got returned. So right here would be the fake count star. Yeah, so here we said 100, and we got 2, which is irritating. Well, I find it irritating, but if that works, then it'll work for you. But it does return the count, right? So 0 is the error, the return code, 2, how many rows got returned, and then 4, 4, and 5, 1. Those are the rows that got returned. No, 2, 4, 4.
That number of columns.
No. I think that might be a typo. I'll check that afterwards.
Would that be row count?
Right, so
Like the columns or the rows are.
yeah, the rows are tab separated as well. And it has to be a multiple of however many columns you specified here. So that also happened to be 2, which I guess is not a clear example, so I'll add in another column just to make it clearer. All right, so 0, 2, 2 rows returned, and then 4, 4, 5, 1. These are the sets. The next example is basically an insert statement. It's the index ID and then a plus sign. The plus sign is just basically we're going to add a row. And then same thing, there's a 2, how many arguments follow this, and then 6 and 6. And these map exactly back to the columns that you specified when you opened the primary key, except of course in certain circumstances. So we inserted the row successfully 0, 1. Columns that don't have values specified, for example, if there were a 3rd and 4th column in that table, they will just go to the default value of those columns when you insert them. This can be a little bit confusing, which is why I always go back to always specifying all of the columns in the table when you access it, unless you're absolutely sure that this is going to do exactly what you want it to do.
So if you have one of those stickers on,
Timestamp is not supported.
so if I had a table that was ID val updated at, which was timestamp on,
No.
that's not.
Right. Sorry.
So basically ID.
Yeah, so for the longest time, HandlerSocket didn't support auto-increment, and that was kind of a deal breaker, and there were various ways to get around it, but it was eventually fixed, and it works and it's fast. But one of the things they still don't support is timestamp. I do expect that to be soon because it's on the request list, and it's got a lot of votes, so I would assume that they would support that fairly quickly.
Kind of just have your own protocol, right? Is there sort of like almost like a SQL compiler open command? So like if instead of typing the format, you can actually sort of write a
So no, this is like, so here's my, I guess maybe my telnet session isn't the most useful for everybody, but it would be like accessing memcached, right? You use Perl, PHP, Python, Scala, whatever. You instantiate a new object and you just do CRUD calls here. Like open index is the equivalent of a get, right? Or, well, it's the equivalent of opening the index. And then execute symbol would be the get. So you don't actually type in SQL. These are API calls.
What's the like 0 equals 1 1 0? Doesn't sound like the easiest program, right? Like,
Oh, it's incredibly easy, right? So just walk through this, right? So we're using the Perl module, trivial, right? The arguments, I separated them out because it's clear and I'm big font. Host is localhost, port 999.
that part.
Right, so this is all easy, right?
Yeah.
Open an index, right? This is exactly the same thing that we looked at in the telnet session. We give it a unique ID, right? That's just, this is how we're going to refer to it for the rest of the script. Which table, or which database, which table, which key, what columns to get. That's all simple. We're just dying if something goes wrong. Execute single, right? This is just, what do we want to, what index do we want to access? This is an equal sign. It's much simpler than issuing an SQL statement, right? And then you have an array ref, and then limit 1 offset 0, right? I mean, it's pretty, like,
So in that case, when we brackets the array, you're saying I want the first column, I want the IDs where?
the one, that's where, right? So when we open the primary key, there's only one column, and that's the ID, right? So the one is where ID equals the number in brackets,
Oh, so you
right?
could have put 1, 2, 3, 4 because that's my basic IDs.
Exactly.
It doesn't have to be one.
Exactly, right? So if I had, for example, a multi-column index, I could say 1, 1, 2, 3, which would be where ID equals 1 and val equals 1, 2, 3. So you can pass an arbitrary number of numbers here. So if on this table I had a key called like IXID on ID and val, and I opened IXID, right, that was the index I referred to, then I'd need to pass two things into the where clause, ID and val. So,
Is it comma separated?
Yes.
Okay,
Yes.
so it'd be like 1, 2, 3, 4,
commas, but yeah. AOE or ONE, yeah. So
And do you have to tick the carrots like you do in MySQL?
the,
You know, like you say where name equals Aaron, and you've got to put a quote around it, that too?
yeah. And then regular language escaping rules apply for single quotes and things like that.
So the ID number that you're passing there, does that have to be unique for every single word that's being generated? Or is that just during that execution?
No, the open index and then 0 is what you mean? But that is what I just arbitrarily assigned. It's just some 32-bit number in case you want to have some large number of indexes open at any given time so that you can manage multiple ones. And think of this in the context of connection pooling or index pooling, right? If I say, okay, I have 100 indexes and I'm just going to keep 100 open indexes and hand them off as needed, that's, or
So
utilize
it's
them.
not like you need like that table,
No.
just the execution of that.
Yeah, so this is local. So my instance of this, somebody else can use a 0 on another index.
Okay.
And it doesn't have to be 0, it can be 1, 2, 3, 4, 5, whatever. But it doesn't have to be unique. If, for example, if the next line was opening another index, you could use index ID of 0. It would close that index implicitly and open your new index.
Got it.
Right? I use 0 just because it's a nice logical starting off point.
So in the field, would you use variable like dollar sign?
Yeah, and that's, that would be user supplied or If I log in, then the query would be, you'd open up the user table on the username index, and it would be equals, Ryan, comma, and then a hash of my password, which would equal, sec star from user where username equals Ryan and password equals some hash. Yeah?
So when you open the index, you get from the server side, right, for that connection.
Mm-hmm.
You also have to manage like that to store.
Yeah, and this is going back to the configuration variables, why you don't want to set these things too high, because that's a lot of memory, resource consumption, because you could conceivably have a whole lot of access here. So something to be careful of. Excuse me? Yeah, as long as they have a unique index ID, right? So if I, again, open an index and call it 0, and then open another 0, it closes that first 0. So you can have 32 bits. Yep. Yep. Yeah. But again, if you go outside that 32-bit range, MySQL will crash. So be careful with that. Yeah, it's all, there's no separate buffer pool for HandlerSocket. It still uses the InnoDB buffer pool, which is a good thing.
I probably have some very basic questions, but really, they're not as, it's just like lower level. The reason is because what I do, I build databases and I do research, and I have my Java application and my driver. Pretty much everything is straightforward.
Mm-hmm.
But when you see you just work with primary keys, so how can you display all your other data if you don't call to all the other related data for a specific record? I don't see that happening here.
So you don't see getting all the rest of the data?
Yeah.
Right?
Let's say we work only with primary keys, so how can it?
Well, so the workload that HandlerSocket lends itself to is, primary key type lookups or index lookups, right? So if you're doing scientific research with very complex queries, HandlerSocket is not for you, right? This is going to be for something, again, like I hate to say this example all the time, but like a Facebook game, right? Where when I log into, what's a Facebook game?
Three Towers.
When I log into 3 Towers, right, it says, okay, here's your Facebook ID, and it's going to go get some set of data based on my Facebook ID and only my Facebook ID.
Okay, that's it. And now all that set of data, how is sent out? It's just with curiosity, how all that set of data is sent out to the user.
Okay, so then here we go. We've got the result set. Right? This is the result set. And we can do whatever it is that we want.
The result set could be anything. Like
Yeah.
in one of my applications, I have actually a method that builds HTML page
Mm-hmm.
and send them out to the and that's the result set. And I have it like that because actually the computer I would make it to really fast with the web page.
Mm-hmm.
So people are getting all the related data, but it's in the web page.
Yeah.
Similar here.
So yeah, let's say,
Result set,
if there were 100 columns that we were accessing, then we would just get a larger result. And we would be able to access those 100 columns and do whatever, build HTML, perform some calculation, or what have you. This is just, a regular result set.
all right.
Just like if this were an SQL query, you get that result set and you have to then do something interesting with it.
Okay.
Good? All right. I hope none of you ever have to telnet into your server and do this, but it can be very useful, right? Especially because the
Quick question, so it only supports one operator per line, right? If you had like 2 columns in the index that you want to find greater than all the columns.
right. So you can't do if I had ID and val as a compound index, you can't do where ID equals 1 and val is less than 6. No, that's Not, no. Someday. But again, this is, when we start getting outside of the primary key lookup, the performance begins to degrade. Then you're like, oh, yeah, let's just add support for joins. No, let's add support for unions. And, then all of a sudden we've got another relational database management system, which we don't want, because the primary key lookup it's proven to be something that a lot of applications do, which is why we have Redis, which is why we have Tokyo and Cassandra, right? Now, we just want to build that functionality into MySQL. So we've already got relational data stores if you want to do complicated things, but this, it's very, very specific. So it's not going to help everybody, but it has the potential to help a lot of applications. Yeah, yes. I mean, the clients are very weak at this point, right? Ideally at some point you'll be able to connection pool and pool indexes, but none of the clients are advanced enough to really do that in a good way. So no, it's dropping them, creating new ones. But there's no authentication. The protocol is very, very small, right? MySQL is super chatty compared to this, right? So the connection is very cheap. Any more before I go on? All right.
Do you suggest that kind of schema that you only have a few columns in a table rather than columns in every one primary key?
No, not at all. I mean, I'm limited by a huge font and a small display here, so I choose 2 columns. But generally speaking, it's the columns that you access. Like in your Castle Facebook game, right? I'm going to have how many loads of Lupin I have, or knights, or things like that, right? So you can store 100 different columns and access them all, right? But you don't want to. This is just like with any other database system, not just HandlerSocket. You don't want columns that you don't access in a table that you access frequently. So if there's a set of core data that you access and change frequently, you might want to separate that out from data that does not get accessed frequently and change frequently.
Can you have concurrent results then from that same column?
Well, I can pipeline multiple requests and get them back. Is that what you mean?
No, for example, you have 2 tables and kind of have it all in one page, like 2 record sets in one.
Yeah, just like in MySQL, I mean, they're not asynchronous, right? I can't issue a query or issue a request and then issue another one on a separate table and not wait for the first one to return, right? So you have to request, receive, next, request, receive. But then you can combine those and do whatever you want, just like you could a regular MySQL result set. Does that answer your question? Okay. All right, so we're wrapping up here. We just have a few slides left. Logging. Will not write to the general log or the slow query log, which is okay because it's not SQL. And we don't expect it to be slow. If it's slow, you're going to see it manifest itself elsewhere. It creates RBR events in the binary log for write operations. That way they can get replicated. But RBR has issues. Yeah, role-based replication. Right, because there's no SQL associated with it. Yeah. So it will get replicated, with the usual caveats of role-based replication. And so you can actually see it if you do the MySQL binlog -vvvv. So you can see what it affected. Yeah, don't use this. You can't use this in that environment. Yeah. It will write stack traces to the error log, which I found extraordinarily useful, especially in earlier versions. Limitations and gotchas. It won't use the query cache. Which is generally okay because a lot of my customers don't use the query cache because it was quite a bottleneck for a long time. And it used to not invalidate the query cache, which was what this slide was originally about, but that's been fixed, yay. And then security. The biggest security limitation is that there is no security. There's no authentication, so everybody can log in. Anybody who has access to that network segment can log in. There's no access control, so once somebody is logged in, they literally have the keys to the kingdom. They can get data from the MySQL user table, get password hashes, they can change password hashes of legitimate users. And finally, there's no accountability. We have no idea of telling what was done by whom, unless, of course, we have binary logging, but even that's not going to help because we don't know by who. So I strongly discourage you from keeping any sensitive data or personally identifiable information in a database that has HandlerSocket running. Question? Well, no, I've yet to see anybody using it in production. B, again, these are like the Facebook game type of people, right? So they've got a private network and, you know, anybody in the 10 space can access these things, but, you know, it's not any information that is, you know, it's not subject to PCI, it's not subject to anything like that, so, yeah.
It's the same as security on these dashboards.
Exactly, exactly. Yeah, which is, it's actually one of the biggest feature requests for this. I mean, it should be fairly trivial to be able to read the MySQL user table and figure out the grants, but, you know, that's not the use case, that's not the problem they're trying to solve, right? The guys that wrote this have a very specific problem, and that problem does not involve secure financial data or personally identifiable data, so they don't care. If somebody really wants it, they're going to have to write it, and they're going to have to patch it themselves, which is unfortunate. But because this is
a simple option, just disable rights.
yeah, and yeah, by you can disable rights by leaving out the listener, the handler_listener_WR, and that will just disable it. And that's, you know, that's a great way to do it. I mean, there are other reasons to disable write as well, but I think that's going to become the most common use case is just for reads, you know. No, it's not in MatKit yet, and I'm excited about it being in MatKit. Like, most people may not know this, but MK-Query Digest can parse memcached so you could do a query review just on memcached traffic, just like you can on MySQL traffic, and figure out what requests are taking the most amount of CPU usage and things like that. So I want that for this. I think that would be a very useful tool. I wrote Magio's checks. They're pretty basic because it is, you know, a pretty basic system. It's basically, can you connect, can you get a record, can you write a record, all as well. And then instrumentation for PHP, it's an application level instrumentation that's very useful for diagnosing code level performance problems, not database level, but I'd love to see it in there as well. And questions, answers, comments? I fully expect there to be binary protocol very shortly, right? I mean, that's, how long will it take for, yeah, I fully expect that. And it's changing very rapidly, it's very actively developed, so I wouldn't be surprised to see binary protocol very soon.
When you say fetch, so if I have, let's say I have an ID that's named name and then binary date that's, if I say, but I'm not doing my where, I'm doing my where on the ID, not on blob and not on text. Can I still return that image, that binary? I just can't search on that binary?
You can't search on it. I have not tested, yeah, I haven't.
Basically what I want to say is give me all the columns where ID is my
I will answer that for you later. I don't know. It's not, I haven't tested. Timestamps are not supported. You can use dates and whatnot, but timestamps, because of the nature of their default values, right? Like auto increment was not supported because it was based on SQL, right? Let's see, what else is not supported?
But that's only on write, not on read.
Right, you can read, yeah, you can read all the standard data types. They've gotten rid of most of the huge deal breaker limitations that were there from version 1, but I think timestamp is one of the last holdouts.
What happens when I open an index and during that period of time between when I open it and I read values out of it and then make it first on, you know, the actual original record? Is that I only get basically the stale version, right?
Mm-hmm. Well, where did the write come from? If the write came from HandlerSocket, you get...
No, from the original data.
Then you're fine. Then you get the real version.
Then I get the real version.
Yeah. Yeah, so this is why a lot of people are going to do all of their writes from just SQL.
Those, when you get them back, are they looking at separate format, or can you get a different format?
No, it's just depending on the client, right, you can get an array ref or something like that. I'm sure in PHP you can get an array. But that was just on a tab, or on a, when you turn it in, yeah, that's just the raw protocol. So a good client is going to abstract that all for you. So, you know, in our Perl example, right, this is just a standard Perl structure that we can interact with as usual. No, I mean, you have the various per connection settings, right? So if you've got large buffers associated with each index connection, then it's going to use more and more memory. But no, I mean, as long as that's small and you have enough memory and you've got enough file descriptors, you're fine. So you're going to be effectively limited just by the number of threads, right? That's basically your limit of concurrency. Like from a client perspective, you can open them, but they're not going to be executed in parallel.
Right, I mean, the reason that I hear there's a large number of clients, open a connection, hold it to the hold of the index. But obviously not all those clients that can MySQL simultaneously. But over time they will. Cache those index on the period of time. I'll open the table.
Yep, you can definitely do that. Yeah, just you're going to have to increase the number of threads as your concurrency grows. Otherwise, you're going to get an increasing backlog.
So if you have an application that catches it,
Insert on duplicate key update. You don't. I mean, you can try catch throw, but that's much less efficient, right?
so if you get a
Yeah, so the response rate is a 0 when it's a success. If you try to insert a primary key that's already there, a unique constraint that's already there, it's going to be a 1, right? So you can say, okay, this insert failed. You won't know why, right? It conceivably be because the table doesn't exist, right? So this goes...
can't differentiate that table.
The error messaging in HandlerSocket is not all that great, right? So there was an error, right? You'll know that. But like, and then you can go ahead and try to update, but it might not be the error that you expect or that you had hoped, right? So MySQL, if you say insert on duplicate key update and it says, well, table doesn't exist, right? That's fine. But that's not exactly what happens with HandlerSocket. HandlerSocket says no. So, I mean, that's insert on duplicate key update is probably not what you want to use HandlerSocket for.
Do an update.
So the update statement. Yeah, so here's the update statement, right? Very simple to read. Update test.t1, set ID equal to 6, or no, equal to 7, and val equal to 7, where ID equals 6, right? So the return code is 1 row updated. Want me to read that again? So we know it's an update statement because of the U. This is an operator that can either be a U or a D for update or delete. There's my delete, right? So this is the index ID, so we know the table that we're operating on, and the index. So so this is how many arguments are next for the where clause. That's so where ID equals 6. So limit 1, comma 0. Update set ID equals 7, val equals 7.
So only update one row.
So this is
very low level.
right. So that would be in Perl. That would be like this, except a different method. So it would be update, right? So then you would do the same thing. You would have the index ID, and then the equality comparison operator for the where clause, and then the value of the where clause, and then limit offset. But yes, the other one was very low level. So then this one is delete from test.t1 where ID equals 7, limit 1, offset 0.
If you update, you update both ID and val, but could you have just updated val? I want to leave the ID 6.
Yes, so you would say
From SIX to SE.
right. So you would either open a different index with a different set of columns, or the same index with a different set of columns, or you could put 6, 7. So again, this is got to be really careful with your write operations.
I think the one that's 0 plus 2.
So plus, I'm doing an insert operation. So insert into test.t1 ID 6, val 6. So the 2 just says, how many arguments do I have after this?
What happens if you put more arguments than
If there is, probably MySQL crash. It's not all that great, but
But then limit offset, the first is like the max number of rows you send back, right? The second.
this is like a standard MySQL limit 1 offset 0. Yeah, and that's what it defaults to, limit 1 offset 0, because that's the common use case of accessing 1 row at a time.
Assuming you can't do joins.
No.
I have that.
I've never tried this with a view, though.
We tried with the
No. If you'd like me to, I could try it with a view.
Why would you ask that? You hate views.
Yeah, if you're using, yeah. Hmm? Yes. So I will test with a view. My hunch is that it's just gonna break.
So this has been tested with
I've tested it with InnoDB. I don't know what other people have done. I've not tested it with partitions, but it shouldn't. Write a blog in the next, over the weekend, it'll be like edge cases that nobody will ever encounter. Partition tables, views, anything else? No. Well, maybe. Use a client. Like, this is just for educational purposes, but. Yeah. I don't know. You shouldn't be generally using this except to, like, debug or go just test connections, things like that. You should be using your Python client or your C++ client. Yeah, this is just telnet to, yep.
So any client library is
Yeah. I've never done it. I've never tried it because, again, this is one of those, I don't have tabs in my column names and my table names. I understand that some people do, but I avoid that. And
I'm sure it was thought of.
yeah, I haven't done it. It's not a case that I've encountered. Yeah. When you figure it out, let me know. Yeah, there are, especially when dealing in the telnet, there's just a lot of edge cases that you don't have to deal with as, when you're using the clients. And that's, again, what makes the client libraries nice.
Anywhere at the moment. Timing, comparisons.
I'm not aware of any, memcached versus Redis versus HandlerSocket versus what have you. A lot of them are different beasts. I think maybe in the original blog post that announced HandlerSocket there were some comparisons with memcached, but I don't know those numbers off the top of my head. And again, it's not just about performance. It compared very well with memcached, if I recall correctly. Yeah, and so comparable to memcached, but persistent, and I don't have to introduce another layer of software in my application stack. But the advantage that memcached has over this is I can scale out memcached. MySQL, I'd have to write much smarter HandlerSocket clients to hash things over multiple MySQL servers. Yeah, so they're different different beasts.
So you mentioned will crash MySQL a lot. How stable is this? Is there anything to crash MySQL?
Well, test with your application. Don't put tabs in your table names, things like that. When it says it's a 32-bit integer that you need to pass it, don't pass it an image object, right? Just basic things that you wouldn't be doing or you shouldn't be doing anyway, and use a client, right?
As long as they're within the rules, it's stable?
Yeah, I mean, there's not much to it, you know what I mean? So unless you're writing absurdly bad data, especially if you're just doing reads, right? There's very little you can do to make things fail. But unless you're writing really bad data, which probably won't be, it's been pretty stable.
It's a sharp knife.
Yeah, yeah.
Select database.
Could be. I hope so, yeah.
When the HandlerSocket crashes, does it crash MySQL completely? Just that instance?
I've seen it crash MySQL. Just, you get the MySQL error log. I've never seen it just crash the HandlerSocket data. I'm sure there's a situation where it could, though. No, but that's not to say that that it does not exist. That's just I have not seen them. This is why we have the InnoDB recovery tools. If it corrupts your data. All right, that's about it for me. Thank you, everybody. Yes, ma'am.